So while astrophotography is a really difficult hobby, it's also super rewarding in a ton of ways. While there are so many parts of this hobby that are amazing, sacrificing sleep is just one of the negative effects that's unavoidable. While there's no way to take pictures of the stars during the daytime yet, there's a ton of different ways where you can maximize the amount of time that you can spend sleeping while your gear goes out and takes pictures for you. And while typically I'm someone that likes to be outside with my gear and experience the night sky, we all need sleep once in a while. So I use some tricks of my own to get some sleep when I need it. In this video, I'm going to show you how you can set up your telescope gear to run itself. Fully automated, just a click of one button. We have a rare forecast for a few clear nights in a row here in Illinois. So on the first clear night, I'll show you how to set everything up for automation, and then I'll come back on the next one to show you how to actually use everything once it's all set up. I've never done a multi-night video before, so I'm super excited to get this one going. So without further ado, here's how you can sleep while you use your telescope. Let's get into it. So before we begin automating our gear, we need to make sure everything is able to be run using a computer. This type of astrophotography requires software to be possible, so no more using that hand controller with an intervalometer. The computer is going to be doing all of that for you. What type of mount are you using? In order for this whole thing to work, your mount needs to have some sort of USB to PC connection. I know for Skywatcher mounts, it is a USB Type B cable, but it might be different if you have a different brand. If you're unsure of anything I mentioned in this video, feel free to look it up. I'm sure it's already been discussed on some sort of forum, and even if not, you can always ask yourself. The other thing you gotta check out is your camera. If you're using a dedicated astronomy one like this one is, then it shouldn't be a big deal. You should already have that all figured out. They all have USB connections anyways, but if you're using a DSLR or a mirrorless camera, it might be a little bit more complicated. You need to check and see if your camera has a way of connecting to a computer. Most cameras are gonna use a micro USB cable, but some have USB-C. As long as it's something that you can plug into the back of your camera that will talk to a computer, you should be good to go. Eventually, we're gonna get all these things that you're plugging into your computer to talk to each other through one piece of software, but for now we just got to make sure that all of them can talk to the computer first. The other thing that's going to be pretty much a requirement for this is to have some sort of auto guiding setup. For me, I use the Orion 50mm guide scope with a ZWO ASI 120mm mini. This was about $200 total online. If you have no idea what I'm talking about, watch this video right here. I go full in-depth as to what auto guiding is, but just for now, basically this is going to perfect the tracking of your mount and make sure that your mount doesn't go askew as it's tracking your subject over a long period of time. As you can probably imagine, this is going to be really useful since you're not going to be able to tend to your mount's tracking and things like that while you're catching up on that sleep. This auto guiding setup will do it for you, and it will do it super accurately. So make sure you have that set up and go ahead and watch that video if you're confused. So something that I'm gonna make a quick disclaimer about here is that my computer is gonna be probably different than the one you're using. A lot of astrophotographers choose to have a laptop out with them with a table, and that's what I used to do, but in the past few years I made a change to using a mini PC. So the only difference between the laptop and the mini PC is that the laptop you can control right there, but I just remote into the mini PC using my phone. It's the exact same as a regular laptop. I'm running Windows 11 on it. It has the same USB ports, everything. It just doesn't have a screen. And if you're curious about any of the gear I'm using, as always, it's going to be linked in the description below this video. Everything from the light pollution filter to the computer to the equatorial mount is going to be down there for you. So this part is always the hardest part. It took me a long time to figure all this out, but I'm hoping I'll be able to speed up the journey a little bit for you. We're going to figure out how to get software set up on your computer so that all of your gear and your setup can talk to one another and automate throughout the night. So the software I use, you may have heard about it if you've watched some other astrophotography videos. It's called Nina. It's free and I really like it. It has a ton of features and it's pretty intuitive. So if you want to download Nina, the link will be in the description and you can follow along with me. Nina's job is to serve as a sort of hub. It's going to send commands to different parts of your setup to do different things at different times. And it's basically just going to do everything you would do if you were right there. You can use Nina manually and just control everything from there, but the whole point of this video is to get it to run by itself. So that's the part we're going to be doing today. So in order to get the computer that you're using to recognize the equipment that you have, you need to make sure that the right drivers are installed. If you don't know, the purpose of a driver is to help tell the computer that this is the piece of equipment I'm using, that the thing that was just plugged into it was a ZWO camera and not something else. The process of downloading it is pretty simple. just go to whatever brand's website you have and search for their drivers, and it'll be right there. All of the big brands make this super simple. Skywatcher has it right front and center on their website under the drivers page. For most mounts, you're going to be using the latest SynScan drivers. I know that's what I use. And then I know other brands such as ZWO, QHY, and Ioptron all have the same sort of thing. So if all your drivers are installed and you have all of your stuff plugged into your PC through the right way, it should all be good to go. Something else you want to keep in mind is if you're using a Skywatcher mount, you'll need to download the ASCOM platform. What that is basically a hand controller that's just displayed on your computer. It's the software that can actually send commands to the mount to slew. Again, this is pretty simple. All you need to do is download the ASCOM platform. Just Google it and it'll be right there. If you download the latest version, then you'll be all set up and ready to go. 2 quick tips regarding that, because this is something that I got stuck on. I had an issue with connecting my mount. I had all the ASCOM things downloaded, I had all the drivers installed, and for some reason it was saying that the port was not found. All that the problem was with that was that ASCOM was set to the wrong COM port. All you need to do to fix this is launch Device Manager if you're on Windows and scroll down until you see Ports, COM, and LPT. Once you get there, drop down that menu and it should display the port that you're using. All you need to do is go to the setup for the ASCOM page and match your COM port to the one that it's going to search, and then you should be good to go. And then the other thing was that the slew actually wasn't working. It was fully connected to my computer, but it wasn't sending slew commands correctly. And I needed to change something called the baud rate. It was set to some really high number. Honestly, I don't know what this is, but as soon as I changed that to 115,200, I think it was all good to go. So I don't know what was up with that, but that was all I needed to do, and it was working well ever since. So if you're in that position where you don't know what's going on for any of those things, try that and hopefully that helps. The thing that's weird is that so many people buy these mounts and I hadn't seen a single person talk about either of those things. I don't know, maybe it's just a me problem, maybe that's obvious to some of you guys, but I couldn't figure it out. So something else that I bet is going to be necessary for most of you guys is to set up something called plate solving. The process of plate solving is actually pretty cool. Your equatorial mounts, when they slew somewhere, when you tell it to slew to a target, there's a good chance it'll be off by a solid amount. So plate solving will tell the camera to take a picture through your telescope, it'll scan all the stars in the picture, and it'll figure out where it's pointed exactly and correct where it's slewed to get you dead center. So this is going to save a ton of time hassling around trying to figure out if you're pointed in the right spot, because plate solving will do it automatically. All you need to do is download a software called ASTAP, ASTAP. That's the one I use. There are other ones such as PlateSolve 2, but I find ASTAP to be the quickest. And then you'll also need to download a star database of some sort. It takes a while, it's a lot of storage, but it's a one-time thing, and then you'll be good to go. Whew, that is a ton of stuff. But if you figured all that out, as far as I'm concerned, you are all ready to go to fully automate your gear. The only obstacle that's left in between right now and fully automating a full night is just troubleshooting, honestly. Just keep at it, keep trying over and over again, fixing little things every night, and eventually it'll all be running well. In astrophotography, nothing is ever going to go perfect on the first try. There's always going to be something little that you need to tweak or figure out, problems you need to solve, but just try to remember that this is what makes the hobby so rewarding. This is what makes the final image so enjoyable. At least that's how it is for me. So you should be all good to go. One last tip that I have for all of you guys is just make sure that you're actually set up properly. Take that extra 5 minutes and really nail that polar alignment. Make sure that mount is fully leveled and that you're totally balanced in both axes. If you really are planning on fully automating everything, then you're not going to be there to make quick adjustments on the fly. You got to make sure that everything's perfect and ready to go before you start imaging. So if your mount isn't balanced, leveled, and properly polar aligned, then everything else is going to be downhill from there. So the plan for the rest of this video is I'm going to walk you guys through how to use Nina manually and just set a sequence of images and send slew commands to your mount and everything. And then once we get that second clear night that I was talking about, I'll show you guys how to fully let it do everything on its own. so it is officially go time, and that means it's time to do my focusing and polar alignment routine. So I'm going to show you guys exactly how I do that, because this is going to be in the Nina software. All right, so here we are inside of Nina. If you've done everything correctly, you should be able to follow along with me and get this all set up for the first time. I'll show you my entire step-by-step routine that I do every night when I'm getting my stuff set up for the first time. So the colors, if you're downloading Nina for the first time, should look a little different. I've changed mine to be black and red. It's nothing to worry about, just keep that in mind. You can see on the left side here, we have the set of drop-down menus for like our overall different things that Nina can do. So you can see one of them is for framing. That's one we'll use a little later. One's for taking your flat frames. The sequencer we'll use a lot. All of these are the different areas that Nina can help you out in terms of imaging. For right now, we are going to be in the equipment tab because we need to connect all our stuff. So again, if you've installed your drivers and everything's plugged in and turned on correctly, this should be no big deal. First off, in the camera tab, you can just select this drop-down menu and select whichever camera that you're using. In my case, it would be my ZWO ASI 533 MC Pro. So I'll just hit the power button there and connect, and then it should show a menu if you have a cooled camera with the sensor temperature, and then you can control everything from there. So I'm actually going to start cooling my camera now because it's a little hot tonight. Then you can go down and connect all your equipment. But if you're like me, you don't have any of this, so the next thing is the mount. Again, I just have mine set already, but you can do the drop-down menu and select yours. Mine is going to be the HEQ5/6 because that's the driver that I have installed for this mount. That's the one it uses. So I'll hit the connect button there, and everything will get powered up. There we go. So you can see this is the ASCOM software I was talking about. That's the dialogue for ASCOM. It's like a virtual hand controller. So Nina is going to send a command to ASCOM to slew it. So ASCOM is going to be the actual software slewing it, but Nina is connected to ASCOM, so you can do it all through Nina, if that makes sense. So we can minimize the ASCOM window. And then the last thing to do is connect your PhD2 guiding software. This is going to be a little different. I'll walk you through how to set this up for the first time. So in the little settings panel you see up here, that little button, you can click on that, and here's where you will tell Nina where your PhD2 application is located. So if you put the right path into here, it should be able to open the application from there. So make sure that's set up first. Press OK. And then if you connect PhD2, if you hit the connect button, it should launch the software automatically on its own and get everything connected. So as long as you're set up, it'll work perfectly. So you can see I hit the connect button, PhD2 will launch, and then it will connect the camera and the mount and start looping sub-exposures. So, and then you can do, if you have an autofocuser or a rotator, you connect that too and do the same thing, and it'll be the same process, and just make sure you get everything connected and it'll be all good. All right, so here is gonna be my routine that I do to get my mount precisely polar aligned and my telescope focused. So the first thing I'm gonna do is unpark my telescope. It won't let you slew anywhere if you're not unparked first. So I can go to ASCOM and hit the unpark button, and that'll let me slew it with the camera. What I'm gonna do is I'm going to use Nina's 3-point polar alignment plugin. It's a third-party addition to the software that was made by someone else, and you can download it from the plugins panel at the bottom on the left there. It is literally essential to everything I do. I don't polar align using my polar scope. I have a huge tree blocking my view, so I actually can't, but even if I could, I would still use this plugin, and you'll see in a minute. It lets you get much more precise than the reticle could. It gives you exact numbers and exact measurements to move your mount so that you're perfectly aligned. Before we do that though, we have to set up plate solving. You can see in here in the options panel, at the bottom you'll see plate solving right there. And then if you go into the plate solver settings here, similar to PhD2, just put in the path for your plate solving software and it'll be able to read that just fine. You can set things like your exposure time and your gain and your radius. I typically have my gain as high as it can go for maximum sensitivity. The exposure time, you just want to find the sweet spot for your camera. With trial and error, you'll be able to get that in no time. Now with that out of the way, we're actually going to go to the flat wizard panel, but we're not going to take flats. All we're going to use is we're going to use the slew to zenith command. So I'm going to press this button and you'll hear the mount is gonna start slewing to a position that is straight up in the sky. We're gonna be using this as our spot to focus. This is just the spot that works best for me. If you have other spots, obviously, in your area that work better for you, use that, but this is the easiest for me because it's just a button and I can slew there. So we're at the zenith, and I'm gonna quickly go into ASCOM and press the sidereal button to start tracking. Now we're not polar aligned yet, so it's not gonna be good tracking, but it'll be enough to focus. So now that we are in our position for focusing, we can go to the imaging tab, and this is where you're able to take manual exposures and view your shots through your camera. So if you're using a DSLR mirrorless camera, this is where you're gonna be seeing your sub-exposures, not through the back of your camera anymore. What I'm going to do is I'm going to set my exposure time to 5 seconds. I'm gonna set my gain to the highest it can go, which is 400 on this camera. And then I'm not gonna save the shots, but I am going to loop them over and over again. And then if we hit this button, we can see that it's going to start looping 5-second sub-exposures. And then when the first one comes in, you can see that, boom, those are our stars. So what I'm gonna do is, it actually looks pretty good for a first sub-exposure. This is just blind testing. I'm going to zoom in a little bit, and I'm gonna find a star in the frame here, in the zoomed in view. You can see that we do have some donuts there. So I'm gonna punch in all the way here, and I'm gonna make subtle adjustments to the telescope as it's looping sub-exposures. So with the next sub-exposure coming in, you'll be able to see that we are going in the right direction. The star did get smaller, so I'm gonna keep going that way. And basically, you're just gonna do this until you can get this star as small as you possibly can. Once the star is a pinpoint of just a few pixels, or however small that may be for your telescope, you're in the right spot. So I look to be in about as best focus as I can be right now. So now that the camera is focused, it's time to polar align the mount using Nina's 3-point polar alignment feature. So that's exactly what I'm gonna do. I'm gonna stop looping my sub-exposures now, and then if you've installed the plugin and everything, it should appear at the bottom of the imaging tab right here. So if we switch to the 3-point polar alignment feature, you'll be prompted with a bunch of these dialogues here. Right now we're pointed straight up. It's gonna slowly rotate along this axis and take 3 pictures and figure out, based off of its rotation, it's gonna triangulate which way it's pointed in this direction. And then after doing those 3 points, it'll give you the adjustment, and you can make the adjustment from there. And then you can keep running it until you're fully centered. So exactly what I'm gonna do here is I'm going to turn off direction east. Now the reason I wanna do that is because my mount is facing the west side, as in the telescope is on the west side of the mount when looking at it from the polar scope side. So I'm gonna turn it off, that way it's not gonna go backwards and crash into the mount. How 3-point polar alignment works is it slowly rotates along its right ascension axis and takes 3 different pictures of the night sky and triangulates the way that the mount is pointed based off of those 3 pictures. Through its rotation along the axis, it can figure out how exactly it's pointed, and it'll give you how far off you are. So I'm going to turn off direction east, and I'm going to press start from current position. My gain is set to 400. My exposure time is set to 5 seconds. My point distance I'm going to leave at 10. So watch what it does here. So I am going to hit play, hit the start button, and it's going to take its first picture. This is literally after I just placed the mount down roughly in the north direction. So you can see it's slewing along that axis. It did a little adjustment, and it's going to take another picture, and it's going to slew along the axis for the last time, and it's going to take its final picture. And then once it takes that last picture, it's going to give you the error in each axis. Now it's probably going to be a ton because this is really rough. So this is something I'm actually not surprised about. The altitude isn't bad, but the azimuth is. So as you can see, altitude is how up and down your mount is tilted, and azimuth is your left and right. So it tells me to move left a lot and move up only a little bit. I typically run it 3 times because the adjustments that you make, it can only give so much precision if you're really far off. So I'm on my 2nd time now. Okay, so as you can see, I just finished my third one and my total error is under 5 arc minutes. So that's about good for me. That's about as precise as I need it with my focal length telescope. If you want, you can get it more precise than that, but that's about good for me. So that's my benchmark. So I can hit stop on that, and once you're done with that, your setup is fully ready to be automated. Again, for tonight, I'm just gonna be using Nina manually. It's still gonna take an automatic series of pictures, but I'm gonna save the automatic mount slewing and everything for tomorrow night. Here's exactly how we're gonna go about taking a picture tonight. We're gonna head first to the framing tab over here on the left. This is where you can get an accurate representation of what your target is gonna look like in the field of view of your camera. As you can see, you can plug in the width, height, pixel size, and focal length of everything. You can just plug in the stats of all your gear, and it will simulate a field of view of that target that you're trying to shoot. So, a little late in the video for the reveal, but the target I'm going after tonight is going to be the Tulip Nebula. I photographed it last year, doing the same thing this year. I'm just getting more data, so that's exactly what we're going to do. In the name box, we're going to look up Tulip Nebula. This is something that Nina can be weird about. Sometimes you need to put the catalog name of the target in there, so that's what I'm doing now. So SH2101, there it is. Click on that, and then if you hit load image, it'll pop up with a view of your target with the field of view with your setup. So you can see that's what it's going to look like. And then all I need to do to get it fully centered just like that is scroll down a little bit here and press slew and center, and it's going to do exactly that. It's going to slew, figure out how much error it was off by, and then it's going to correct itself and get it dead centered. So here we go. So it is slewing currently to the Tulip Nebula. The Tulip should be about right in there. So it said plate cell failed, but it's okay because I can see it in there. If we go to the imaging tab, so as you can see, it's pretty obvious that the Tulip Nebula is right in there. So it's at this point in the video where I want to remind you that trial and error is going to be absolutely necessary. Of course, I'm able to do this on the first try because I've been doing this for 3 years now, this exact thing. There's going to be kinks in your setup. It is totally natural. You're going to have some sort of jolt along the way every single step of the way, but that's part of the fun in it, is figuring out the problems with your own setup, and that's what brings the satisfaction to getting your final image. Although it would be great if you could follow along perfectly with this video and get going perfectly the first try, that's just almost always not the case. My goal is to just give you guys an idea of my workflow and what works for me, so hopefully you can adopt that into your astrophotography life. So with that being said, let's get going on figuring out how to take some pictures of the Tulip Nebula. So, okay, we can see that we clearly have the Tulip Nebula in here. So now that we know that we're centered and tracking, we can go into the sequencer tab. All we're going to do is just press add new target, and then we can see we have a bunch of options here. So we're going to name this Tulip Nebula. We'll get all the coordinates and everything plugged in there in a second. But this is where the magic happens. You can set the number of exposures or pictures you want to take, set the exposure time for each picture, figure out your dithering, your gain, your offset, everything here. If you want, you can even send slew commands to your mount through here too. Center target, slew to target, start guiding. Since we're already centered and slewed, since we did that manually, I'm not going to check any of those, but I am going to check start guiding so that it starts guiding automatically while it starts taking its pictures. You can see the options up here, such as cool camera, unpark mount, meridian flip. You want to have all these on typically, unless there's some sort of special case where you want one turned off. It's pretty self-explanatory what all these do. So for me, I want to take 3-minute pictures here. So I'm going to put in 180 seconds for the time. And then I'm going to want to take, let's start with 50 and we'll be able to see how many hours of exposure time that is. So I'm going to put 50 in there. So it does the math for you. It's about 2.5 hours of exposure time, brings you just past midnight. So I'm going to say double that, get 100. That'll bring me to about 2:30, and by then the Tulip Nebula will have hit the trees. So that looks good, and then I'm going to dither every 2 frames. This is just how I like to do it, by the way. As you get more experienced, you'll be able to figure out your own way of doing things, but I typically find that dithering every other image is good. My camera's set to unity gain with offset 70. That's just how I do it with every picture. And then once that is all set, you can see that we are going to take 100 3-minute exposures dithering every 2 seconds. And when I hit the play button, it's going to start guiding too. So that's exactly what I'm going to do. So you can see at the bottom left, it'll be giving updates as to what it's doing. So you can see it is settling PhD2 now, and you can see that in PhD2, it found its star and it started guiding all on its own. And then now that we're actually guiding, it's going to settle for I think about 15 seconds. And then once it's done settling, it'll begin its first sub-exposure all on its own. And in the sequencer tab, you can see these options at the top. Over here, we have warm camera and park mount. Since those are turned on after your sub-exposures are finished, in this case 100 of them, after the 5 hours of 3-minute exposures that it takes, it's going to park the mount, bring it back to its home position where you started in all by itself, and then it's going to warm the camera. These are just things that Nina is very good at, where this is the reason why you want to be using a software like this. So we can see if we go to the imaging tab, once this 3-minute exposure is completed, we'll be able to see it in here, and then you can check on your guiding below, and after 3 minutes, or in this case a little less than 2 minutes, we'll have our first sub-exposure in. This is really exciting. So we're almost at the point where the first sub-exposure is going to come in, and this is always the most exciting part of the night for me. I love seeing this first sub come in and just seeing the nebula in full detail. You can sort of get an idea of how your image is going to look like after seeing that first sub-exposure. And boom, there it is, dust motes and all. So you can see in there is the Tulip Nebula in all its glory. You can imagine 100 of those all blended together and then compiled on top of years previous data, and we're going to be able to get a pretty good image. And there you have it. If everything went smoothly for you, hopefully eventually you got your mount and camera able to be working automatically and taking pictures on their own. This is just the bare minimum of what Nina can do. After we collect all our sub-exposures tonight, I'm going to come back tomorrow, like I said. Now that your setup is fully ready to go and polar aligned, you'll be able to send slew commands automatically at a specific time, have your mount automatically center a target and start taking pictures all on its own without you having to do anything. It's pretty incredible. So I will come back tomorrow and update you guys on how everything went. So we're back, it is the next day, and I'm going to show you guys how to get your setup to run fully automatically now. So you're not actually going to need to be out there with your telescope if you don't want to be. Since we spent all that time and effort on getting our setup accurately polar aligned, balanced, and ready to go, we're not going to have to do anything tonight other than just press a few buttons. So I'm going to show you guys how to set up the program in Nina so that it can send all the commands it needs to, and then you'll be good to go. So as you can see, I am inside Nina right now. I'm on version 3.1, so if you're wondering or if you're watching this later, that's the one I'm on. And here's exactly how I go about starting a sequence. So the first thing we're going to do is we're actually going to go into the framing tab here, not the sequence tab. I'll show you why in a second. So this is when you're going to want to type in the target that you want to capture tonight. Since I'm doing the Tulip Nebula, I'm going to do that. So for some targets it's weird, sometimes you have to put in the catalog name. For the Tulip Nebula that's the case, so SH2. Okay, so as you can see, it has loaded up an image of the Tulip Nebula and then the frame of what the camera is going to see with the telescope. If this looks off to you, here's where you can put in your stats. It's easy to Google. Just Google your camera's sensor statistics. It'll give you the resolution, if you don't know that already, the pixel size, and then you should be familiar with the focal length of your telescope. So once that's in there and you hit load image, you can frame it up exactly how you want. For me, in this case, I want it right in the center. Great. And then we're going to hit add target to sequence, and then we're going to click legacy sequencer. So this is the sequence type that I used last night, and then I showed you guys how to use. All this is it's a few simple commands. You can slew to your target, center your target, start guiding, and then take a number of pictures. This is great for when you're out there with your setup. It's great in my case. I use this most of the time unless I'm doing this, fully automating. But for our case, we need something with a little bit more control. So how we're gonna get that control is we're gonna first set up everything we can in this type of sequencer, the legacy sequencer, or the more simple one, and then Nina will let you convert this into the advanced sequencer where you can add more custom controls. So that's exactly what we're gonna do here. So this is what I want. I'm gonna wanna cool the camera, unpark the mount, and then I want it to auto meridian flip. I'm gonna wanna warm the camera once the sequence is done and park the mount. So all of these should be on. Slew to target, center the target with plate solving, and start auto guiding should be on as well. And then I'm going to want to take 180-second sub-exposures, same as I did last time, and about 100 of them. Dither every 2 frames. And this looks about good. This looks like what we had it the other night. So now once this is fully complete, you can see at the bottom right here, there's a little blueprint icon. That's going to convert all of this information into the advanced sequencer. It's exactly what we're gonna wanna do. So I'm gonna hit this, and then yes, I do want to bring it to the advanced sequencer. And you can see, whoa, it looks way different, right? There's a ton of stuff going on now. This advanced sequencer genuinely is really advanced. The reason I had you set it up in the legacy sequencer is because it's just easier and faster to get everything like fundamentally set up, and then you can just add in little controls here as we go. Okay, so this is a very important thing. This is why we use the advanced sequencer. We are going to have the telescope automatically slew to your target at a specific time. So it's going to, you can start this sequence whenever you want, but at that specific time that you have set, your telescope will automatically slew to your target. So what we're gonna do here is we're going to search in the top right corner, wait for time. This is the one you want with the little clock on it right here. And we're gonna drag this above unpark scope. So this will just start a countdown to the time, right? And then it'll run everything. So in my case, I used the app Stellarium to figure out when my target was gonna be above the trees. If you have a planetarium app like SkyGuide or Stellarium on your phone, you can actually go outside and just use the camera feature and plan out when the target will go above the trees or when it'll be dark enough to actually start imaging if you don't have any trees around you. So for my case, that's 10:15. So, since this is 24-hour time, this is very important, I'm going to put in 22:15. Very important that you don't type in 10:15 if you want to do 10:15 p.m. because then it'll wait until 10:15 in the morning the next day, and you don't want that. So now that we have this in, once I hit play, it'll start the countdown to 10:15, then it'll unpark the scope, cool the camera, and do everything. And that's pretty much all there is to it. It's not very difficult. The hardest part is getting it set up for the first time, and then once you have this down, it's really easy. So if you want to see me do this, you just got to hit the play button at the bottom right, and it's going to wait. In my case, it's 5 hours and 7 minutes until 10:15 p.m. And then exactly then it'll do everything automatically, as long as you haven't bumped your setup, moved it, or anything like that. The last thing I want to mention before heading out and letting you guys experiment with this is don't play around with your setup at all in between imaging nights if you want to have this work correctly. If you move your telescope or bump it at all whatsoever, there's a chance that everything could be totally messed up, and that chance is more likely than not. So try not to adjust your polar alignment or fiddle with your mount's axes, and especially don't bring it in and then set it up again and expect all this to work the first time. The whole point is it needs to be set up properly and polar aligned for a night before for this whole thing to work with automation. So with that being said, I wish you guys luck. I know it's a lot of trial and error, but I promise you that if you keep at it, it's gonna work out. I've said it before, but the frustrations of astrophotography is what makes it so rewarding when you finally get that image. So if you used this walkthrough in any way to help yourself get an image, feel free to send it to me. I'd love to see it. And with that being said, I will see you in the next video. Clear skies.